Welcome back to Chem 330. We're going to continue our discussion on cycloalkanes. In particularly, we're going to focus on cyclohexane. Okay, so if you remember from the previous video, I talked to you about cyclohexane, right? Right. Now I told you the formula is C6H12 because it follows the same formula as CnH2n, right? Right? And I gave you two different conformations, a boat and a chair. But for now, let's just focus on, just the chair conformation. Okay, I think that requires a little bit more tuning. That's a really badly drawn chair. Oops. So this is like your pool chair. Okay, this is, you get the idea, right? You could draw it this way, or I'm gonna explain it the other way as well. All right. Again, I didn't do a great job with the drawing itself, but we don't want to get stuck too far in here. So there are 6 carbons. One, doesn't matter where you start numbering. For a plain cyclohexane, it doesn't matter where you start. 4, 5, and 6. Okay, let me redraw this one more time. It takes a little bit of getting used to. Okay, you have to just sometimes draw it a few times just to even be able to draw it. All right. Now, we did say, I'm going to draw something here. We know that each of these carbon, each of this is a bend, so that means each of them has 2 hydrogens, right? Each of the 6 carbons have 2 hydrogens, right? That's why I drew that plain structure once. The flat one, it's not flat. Again, I shouldn't even be saying that. That's not flat. This is how it looks like. Each carbon is made of 6. Each cyclohexane is made up of 6 carbon, and each carbon contains 2 hydrogens, right? So I'm going to draw these from now in 2 different colors. Okay, now we see these 2 bonds, right, on top of each carbon, this and this. Okay, one of the bond is axial, okay, that I'm going to give red, and the other is equatorial. Okay, in all these 6 carbons, you have 2 sets of bonds for each carbon. One of the bond is axial, the other is equatorial. Okay, I am going to come back and draw these here. Okay, I'm going to keep the colors the same. So when you see a blue, it's equatorial. So let me actually draw it this way. So blue and then red. Okay, so let me draw all the axial. So this is axial, okay, and this is equatorial. We have 2 hydrogens, right? I'm going to draw them in black so you can get this. Each carbon has a set of axial and equatorial bond. An axial bond contains a hydrogen, the equatorial bond contains a hydrogen. Right, let's come back again, and this is your equatorial, okay, and this is going to be your axial. Okay, and this takes a little bit of time to get used to, but we might spend a little bit more time on this. So if this is equatorial, okay, from here it's easy. If this is axial, right? That means this has to be equatorial, right? That means the other bond on this is axial. You want to be consistent, okay? So this is axial, this is equatorial. Because this is equatorial, the next one, you guessed it, this is axial, okay? And this is equatorial. Because this is axial, right? This has to be equatorial. I'm trying to say sane. By saying this, it's just confusing just saying it. Okay, this is axial. Okay, and then this is equatorial, so that means this has to be axial and the other one has to be equatorial. Okay, now let's go fill it with hydrogens. You just have to remember the first two, and then the rest you can just alternate them. Okay. Okay, so this is axial hydrogen, this is equatorial, equatorial, axial, equatorial, axial, axial, equatorial, equatorial, so axial, and then axial, equatorial. This is very, very, very important. If you don't understand it, then we have a problem at hand. Okay, right? Okay, I am gonna, probably copy this because I don't want to, I was going nuts just saying that because it was just, I'm just gonna copy this because that way I can reuse it. Okay, so let me delete this. Okay, so let me get my eraser and erase this. Okay, because that's what I really wanted to do, was that. All right, so the rule is, okay, right now this is a plain old cyclohexane, right? Right? Let's say we start to have substituents on the group. Now we are going to tie the idea of cis and trans. We will not use Z and E for single bonds. We will only use cis and trans for single bonds. Yes, we can have single bonds for cis and trans as well. Okay, so the rule is, let's say we're going to say redraw this. Okay, I'm going to redraw this. But this time, say I'm going to erase this first, get rid of this. Okay. Let's say instead of a hydrogen, say I have a chlorine. Okay, maybe get a different color, maybe a purple. Okay. Okay. So let me get my eraser and say I get rid of one of the chlorines. Okay, and then I say my Cl. Okay, and then say I get rid of this hydrogen as well. Okay, and then I am going to replace that with the Cl as well. Okay, now this is not a plain cyclohexane. Okay, I'm going to copy this molecule one more time so I can put this over here. Okay, and I'm going to do the same. Actually, no. I'm going to delete this and replace this with a Cl. What do you see is different? Well, in this is plain cyclohexane. This is substituted with chlorines on two separate carbons in both of these cases, right? Now here, the chlorine, let me get my black back. In here, this chlorine is in equatorial position, right? This is equatorial, this is axial, right? Here, this is equatorial, this is also equatorial. Okay, anytime you have a substituent, if the substituents are in the equatorial position, then that molecule is more stable. Okay, so let's write the rule. Okay, any substituent, okay, again we may have relativity at some point, but any substituent in the equatorial position, okay, equatorial position leads to more stability. Okay, I'm just going to be running out of words here. Leads to more stable molecule or more stability. Okay, so we have chlorines, and in both this is plain cyclohexane and this is cyclohexane with the substituent, right? You see, I'm adding a little bit more of new knowledge into everything you've learned. Okay, I gave you the list saying Cl means chloro, right? I gave you that on the previous video, right? Now in this case, before you worry about numbering, let's decide which of these two. Let's call this A, let's call this B. Is A more stable or B more stable? Which one do you think? Read the rule. Any substituent in the equatorial position leads to more stability. Well, we do have one chlorine in the equatorial position here, but the other one is in the axial, right? Here, both are equatorial. So this right here, folks, is more stable, right? It's di-equatorial, whereas this is equatorial axial, right? Now let's get this, okay, and copy it to a new screen so you know I can name them. Okay, okay, and I am going to erase this portion right here. Okay. All right, now let's numbering. Now it doesn't matter where you start with, but conventionally you start from the very top. Again, some of these will change as we do more examples, but for now we're going to start from here. 1, 2, 3, 4, 5, 6, right? Cyclohexane, you cannot write it as a straight chain. That's why it's called a cyclo, because it is in a cyclic ring, right? So as I said, the Cl is chloro, right? So it's in 1 and 2nd substituent, right? So 1, 2 dichloro, right? Cyclohexane, right? Right? And here this is also 1, 2 dichloro cyclohexane. So you can have two molecules that could have two different combinations of axial equatorial, equatorial equatorial. There's one more, which is axial axial. Okay, so this is equatorial axial, right? Right, and this is equatorial and equatorial, right? Normally axial equatorial, right, is cis, and then equatorial equatorial is trans. Okay, it looks like these are adjacent to each other. They're not. Okay, just remember that whenever you have an axial equatorial combination, it is cis, and when you have a di-equatorial, it's trans, because your mind is telling you that these are adjacent to each other. This is not like a double bond. Okay, this is not like a double bond. This is all single bonds. If you actually construct a 3D version of the molecule, the chlorines and chlorines are opposite to each other, whereas the axial and equatorial are on the same side. So that is cis and equatorial. So this is axial equatorial. What is axial equatorial? We're focusing on the chlorine. Okay, they're axial equatorial or equatorial axial, it doesn't matter. And this is equatorial equatorial, so that is trans. Okay, so di-equatorial is trans, axial equatorial is cis. This is not how we learned cis trans when we learned it with a double bond. Okay, we said they're opposite. Here they're opposite, they're not adjacent to each other, but because your mind tells you they're adjacent, but they're not. Okay, if you actually construct a 3-dimension of this molecule, you would see that these two would be opposite to each other, which is why I'm telling you this is a clue. If it's di-equatorial, it is trans. If it's axial equatorial, it's cis. Now which one is more stable? We already did that. It is B. Now you cannot write it as a straight chain, you have to treat it as it is. Okay, so that's how you name cis and trans. This is 1,2-dichlorocyclohexane, one is trans, the other is 1,2-dichlorocyclohexane, and that is cis. Okay, we will practice more compounds, but I want you to first get used to this idea of being able to do this. Okay, this is foundational. If you don't understand this, then there's no point in me giving you more practice problems, and you cannot do those as well. If you don't understand what is on the screen right in front of you, then you more likely have a problem. Alright, so I'm going to stop this video here. Maybe in the next video I'll just write just 1 or 2 exercise problems and have you solve it and give it a shot, okay, and see what you can come up with. And if you can, then you got the concept. There is no reason to get confused about this. Yes, there are some little rules you have to remember down the road, but keep in mind this will be somewhere around week 5 when we start to learn this material. So yes, there has to be some complexity in your learning, and again we are relating everything back to everything you have learned. I'm not just starting a new concept entirely on its own, and if there is a little bit of new information, I'm highlighting that to you, but mostly you should be building on everything you've learned to get into new concepts. Alright, so I'm going to stop right here, and then in the next video I perhaps will show you a couple more compounds and have you name them and tell me which one is more stable. Alright, stay tuned.